We're going to go through a little bit of programming today for the dice project using the Genie chip. But before we do the programming, what I want to go through is just going to focus on the paper. Before we do the programming, what I want to go through just on paper is what we're going to do. So when you program, you use different functions. I'm going to use, first of all, the start function. We're going to start. Once we start, what do we want the dice to do? Well, you imagine our product. We want the product to activate when we press a push to make. So let's put that in there. PTM. Now, has that push to make been pressed? If it's been pressed, we go down further. If it hasn't been pressed, we're going to go back to the start. So what I'm going to do is just put those two commands in there. You can see, has it been pressed? No, it goes round to the start again. Yes, it has been pressed, and it goes down to the next function. Seems like we're focusing quite a lot at the moment on this little demonstration. Okay, if it's been pressed, then I'm looking to create what's called a random variable. A random variable. So I'm going to say create a random variable where a equals between 1 and 6. Not surprising, a random variable, a equals between 1 and 6. Okay, so now within this chain, a has a value. Once I've done that, I'm going to use the compare function. And I'm going to ask the question, does a equal 1? If a equals 1, because it's a question, it has a yes or a no. If a equals 1, then what we need to do is turn this central LED on. Yeah? If a equals 1, so LED 1 goes on. That means it goes high. I'm also going to put a wait command in there for 0.5 of a second. Right. If LED 1 goes high for half a second, LED 1 also needs to go low. So put that in there, LED 1 low. And once that's happened and once that's turned off, what we want is an arrow going all the way around. Going back to the start again, ready for us to press that push to make for a second time. But what happens if the random variable doesn't equal 1? Well, we're asking here on a compare function, exactly like it did before, does a equal 2? If it does equal 2, then LED 2 is high. Now LED 1 will be this one, LED 2 will be this one and this one. You see, it'll be those two, won't it? So LED 2 high, we're going to put the wait command in for 0.5 of a second, and then LED 2 goes low, and then that goes down. Right, last bit. Of course, this gets repeated again and again and again, but just pay attention to this last bit. But what about now? What happens if it doesn't equal that? What happens if it equals 3? Well, what happens if it equals 3 is we are on a compare function. Again, a equals 3. No goes in this direction. Yes, which hasn't been marked on there. Goes down. What happens if a equals 3? Well, LED 3 comes on. No, it doesn't. LED 1 plus 2 comes on. LED 1 is of course the middle one. LED 2 are those two. So if we want 3, we want LED 1 and LED 2 to come on. Alright? And then of course LED 2 goes low. Now, of course, we can do the same thing here, and that's going to be 4, isn't it? So A equals 4, if A equals 4, then LED, well, LED 2 needs to come on, but also we've got to create another set of LEDs, which will be LED 3. So LED 2 plus 3 goes on high. I'm going to leave the rest for you. I'm sure you get the idea, but of course A has to equal 5 and 6. One thing just to add with this, once you get over here and you're asking the question, the compare function A equals 6, if it's a no, which it can't be, you've got to link it to this root which goes back, but of course A has to equal between 1 and 6, so if you, that effectively cannot happen. Sorry about that, my screen going dark, but I'm sure you get the idea. Alright, now I will go on to Circuit Wizard and I'll make the program on Circuit Wizard using the different functions.